In this our last class, so we will discuss on several example of past year question related to the nonlinear application. So namely the op-amp comparator and op-amp Smith trigger. Okay, so we go to our first example. So the circuit in figure B.5 C1 is used as automatic street light. So the automatic street light, so you know the street light is the turn on and off, the switching of the street light is automatic. So the street light will turn off in during the daytime and turn on during the night. So with the given characteristic of the photoresistor in the B5 C2 and the intensity of light in different condition in table B5, find the suitable value for R. So this is the circuit. If you analyze the circuit, you see this is the op-amp, and then the op-amp does not have the characteristic of the circuit is no loop, okay, no feedback or feedback. So this means that the op-amp operate as comparator. Okay, so op-amp operate as comparator. So the output voltage is either the plus VCC. What is your plus VCC? The plus VCC is here. This is your plus VCC, which is a 9 volt. So the output will be either positive 9 volt or the minus VCC here. This is ground 0. Okay, so this is the operation of comparator. Okay, and then for the comparator, we have the reference point and we have the variable point. Okay, so op-amp has two inputs, inverting, this is non-inverting input, and then we have inverting input. So one of these two input will work as the point where we put where we apply a fixed voltage. So the fixed voltage will be your reference voltage. So this is your reference voltage. Reference voltage. And then the another input port will become the variable port. So this input port will monitor the input and then will give the output according to the relationship between the V plus and V minus. So we know the V out is plus VCC when the V plus is larger than V minus, and V out is equal to minus VCC when V plus is lower than V minus. Okay, so this is the op-amp. Okay, so based on that, we analyze this circuit. So which one will be your variable and which one will be your reference? Okay, the V plus here is connected in between of 200 kilo ohm and photoresistor. Okay, so what is photoresistor? Photoresistor is the sensor that detect the light, whereby where the internal resistance changes depend on the light condition. So it means that if the ambient is dark, it will have different resistance value in comparison when the ambient is light. There is light in the in the daytime. So it means that this resistance is not a fixed value. So when this resistance is not fixed value, so this voltage, the V plus here, will also is not a fixed value. So this is your variable. So this is your input. Okay, so it means that the V minus here is your reference. So this is your V minus here is your reference voltage. So R1, the value of R is important to set the reference voltage. Okay, so the V reference here, V minus is your V reference, and V reference is equal to, using the voltage divider, this voltage drop at the R. So this is R over R plus 100K times 9 volt. So this will become the fixed voltage that is the reference. Okay. Okay. So how we want the required, you need to calculate the R. So when you want to calculate your R, you need to define the suitable reference voltage. So the suitable reference voltage is depend on the condition that you consider. Consider is the condition that you are taking into account. Okay. So this is the automatic straight light. So you know that photoresistor here will the resistance changes depend on the ambient light. Okay. So this is this show the resistance of the photoresistor versus the illuminescence. So this is a photoresistor resistance of the photoresistor. So photoresistor here, I put it RP is higher when the light is lower. Okay, so this is the characteristic of the luminescence. Okay. So what you want to do is when we design the street light, automatic street light, okay, auto street light. Okay. We consider the transition time. When does the light turn on from the turn off? Yeah. When does the light switch from the off state into the on state, or the other condition? So the answer is the transition time is during the early morning. Yeah. Or during the early morning, or during the what you call it, around when the sun set, the sunset. Okay, so this is the transition time. So here, if you see the table, you find there is the condition of sunrise and the sunset here, and at this time the illumination is 10 lux. So illumination is 10 lux. So the 10 lux here, in this condition of the illumination, 10 lux illumination, the photoresistor value is 100 kilo ohm. Okay, photoresistor value is 100 kilo ohm. So means that if you look at this only this part, let me okay, if you look only this part, this is your VCC is plus 9, this is your 200K, and then this is your V plus. Okay, V plus. So during the sunset or sunrise, the photoresistor resistance is 100K. So here the V plus is equal to, using the voltage divider, 100K over 100K plus 200K times 9. So this is equal to 3 volt. Okay, that's not the final answer. So Okay, so during the transition time, you know that during the transition time, the input V plus is equal to 3 volt. Okay, so this will be your reference. So this 3 volt will become your reference voltage, okay, at V minus. So V minus is equal to, okay, so at this part, so V minus is equal to R over 100 plus R times 9. So R over R plus 100K times 9, this is equal to 3. So you can solve this. Finally, you get the R value is 50 kilo ohm. So this is your answer for the this question. Okay. So if you we want to discuss on the you want to describe the operation of this system. So we know that the reference V minus is the V reference, which is at the 3 volt. Okay, and then at the sunrise, okay, at sunrise or sunset, this is the value of 3 volt. Okay, at night, okay, at night what happened? So at night the illumination is very low, so the resistance here is very high, and then when resistance is very high, the V plus is larger than, okay, this is V plus, the input. So at night the V plus is larger than 3 volt, and what happened is, so since this 3 volt is V minus, so V plus is larger than V minus, so the V out is equal to 9 volt. This is on. At the daytime, okay, at the daytime, since at the daytime the illumination is very high, the resistance here is very low, and then the voltage V plus here become lower. So at daytime the V plus is lower than 3 volt. Thus, so now the V plus is lower than the V minus. So V out will give the minus VCC. So the minus VCC value is 0 volt. So this is, the light will turn off. Okay, that's it for the analysis for this example.